Hello. Hola. Long time no see. Thought I'd make a quick little video of what's been going on down in the shop. A little update on the grease and a couple other things. So yeah, we'll dive right in. And this should be a good time. So make some popcorn, grab a beer, soda pop, whatever you got, and come along. You might be asking yourself, where did the table go? So today I decided that I would spend a little time and take the table off. I've been experiencing some odd like surface finishes in the x-axis direction, and yeah, I decided to go after it. And my first thought was the Belvilles on the bearing side, or the coupling, or the screw itself. So the only way to really get in there was to just tear the whole thing apart, and it's a good time. I was a little bit apprehensive to try to sneak the table off in the enclosure because I hadn't done it before, and I had a little piece of my mind thinking, oh no, like I hope I can get the table off in the enclosure. And everything worked out, and it was much easier than I was anticipating. So yeah, let's I'll dip in here and we'll talk, and we'll go look at some other things, but we'll start here. So once I got the table off, I was able to get a better look, and this is actually the first time I've laid eyes on it, after it's been run a little bit and stuff. And I could see probably gonna want to make some sort of, this is where the table is about flush with the outside of these bearing trucks, and so there is like a slight gap in between here, and you can see here's where the chips and stuff have come in as I've washed the machine down. It's pretty happy though. The seals on these bearing cars, they seem to work really well, with the little caps that go in the rails themselves. If you set them sort of a little proud of flush, like it really does keep the chips out. And as you could tell, it's not really in like the ideal location. So I was happy with that. And I'd recently switched up to a lighter weight grease. I checked out what Highwind specs for for these bearings, and just found like an equivalent on McMaster, and it seems to be working really nice. Like I thought, I don't know if they were all full of shit, but looks pretty good to me. So yeah, the reason I pulled the screw out was there was some odd, like, call it backlash, but it's like it was squishy, springy kind of backlash. And that was, showing itself in, making, like, cutting on the x-axis. You could hear it and see it. So that's what spurred me to tear the table off to get better access to the screw and, try to figure it out. So that's what this video is mainly about. But so this is the screw. It's just your run-of-the-mill 1605 Chinesium double nut, and the plan is to, or I guess the problem, these are supposed to be loaded, and that's what's weird, is that they were loaded a little bit more than this when they were new, but you can see here's the shim. These shims are just loose in here, and like this is your double nut action, and there's a good amount of play like in between these little fingers or dogs or whatever they are, and then these are just free to float around. So I got the screw out. I'm gonna pull it all apart, and I'm gonna try to either find some of these like replacements that maybe are from a different set of screws, like maybe thicker, like they have some sort of tolerance, and I could maybe grab a set that's thicker and then grind them to fit. But if I can't do that, just make new spacers and grind them so we can actually get a proper load on this thing, and see where we go from there. And also going to get a new screw. That was one thing that bothered me from the beginning of this project was these screws came with the ends machined, and whoever did the machining on them just did a shit job. They're not concentric. They're like, whoever machined them must have thrown them in like a 3-jaw or something, which would probably be fine, but I don't know, I just like to eliminate that, and so I think I might buy an unmachined length of screw and see how it gets down with the whole thing, and try to do a proper end on it, as well as maybe add a bearing to the motor side, which it currently doesn't have. But yeah, that's sort of what I'm thinking for this. And it's interesting too, if you've ever taken these apart, like I've had these apart a bunch of times when we were building it, and these tabs right here, all of these things were these screws were tight when I first started, and or when I first put the machine together, and as I pulled it apart, I noticed that they were all loose, and I think that's from the screw is like slightly bent, and then it also, the ends aren't machined as good as I think they should be. So it's like this nut sort of like floats around and has worked these loose, and like these little tabs are made out of some sort of, one step above butter as far as, steels go. So gonna try to see if I can put my stank on these nuts and pimp it up, homie. So if you got any input or ideas, shoot it. But yeah, I think that's the nut. Probably didn't make any sense, but it seems I've been mincing my words more than normal lately. So feel free to be like, you're an idiot. And the table, not really much to see here. I was just glad that I could get it off easily, actually by myself in the enclosure. So the first thing that I saw when I was pulling this apart was this coupling had somehow shifted apart from the other coupling, so wasn't this drastic, but just sort of think that like these fingers, we'll call them, were maybe like that. So that was my first thought. I popped the cover off on the stepper and was like, oh, that's got to be it, like that's the spring, and because I saw that it had come apart. And yeah, so I don't think it's that, but this is definitely on the list to be addressed. And I have a what I would call more an industrial coupling, but it would require a bearing on this side. Like you can't just have the screw mounted to this and just running through the whatever the stepper's got in there. So I don't know if that's going to work, if there's enough room to sneak a bearing in there to use a different coupling, but cross that bridge when you get there. I'm sort of just in the spitballing stages, but this is you're looking at like a mirror from the underside of the x-axis. It's the stepper and the coupler on the screw. Enough with that boring troubleshooting stuff. Let's check out a pimped out vise. This was, I actually just finished this up on Saturday, and this was like a really, really, really awesome, fun, enjoyable lesson in machining, hardening, and grinding, all wrapped into one. And is this light is horrible or what? I don't know. So yeah, this is my little 4-inch vise, and these are some Talon grip jaws that I made for them, and I think they turned out pretty awesome. So I'm looking forward to trying these out. I'm really, my dad's always had a surface grinder. I just never really spent any time on it, and yeah, this was sort of my first project utilizing it, and it was pretty fun. I think what was it? Yeah, this was started out as like some 1.5 by 4140, and I rough machined them with like 15 thousandths for the grinding allowance, and then I hardened them in an electric furnace, a little one over there, and tempered them, and then ground them. I didn't end up grinding. This is the 1/2-inch slot. Like, it's got to be pretty dialed in for the Talon grips there. And I wasn't feeling confident in my grinding that channel, so I ended up just machining it with a coated like carbide end mill, and it turned out pretty sweet. And the only thing I failed to realize was the grinding allowance of, like, it was actually more on this slot here. It was something like 25 thousandths or something, and after I finished up the channel for those, I completely lost any thread relief that I had planned for, because I didn't account for that 25 thousandths that was going to get taken out. So I really don't think it's going to matter for such a silly, lightweight, hobby time application as the Gree is. But, it's always fun to, do things like, that looks like you could get it in a magazine or from the store, like professional. Like, I always like to try to make things professional, even if I'm, making them or, using them in a sort of a home shop environment. But enough with me chatting. And because some of you might ask, this is a homemade heat treating oven. Yeah, it's pretty handy. I mean, you can't fit huge stuff in there, but for making things out of small kind of tool steel things, it works freaking awesome. And got a super easy to use temp controller and a little fire brick and some sheet metal. Cool little latch. You can see it's been around a while. This is sort of a painting bench, as you can tell. There's lots of stuff slopped on there, but oh yeah, I also forgot to mention this little cart for the Gree stuff. This was like an impulse buy, one of those kind of things where you buy this thing and then you get like a free set of wrenches. It's a bit of a shit wagon, but I think it'll work. I say that because for my application, like the drawers, I wish they were deeper. I would have measured before maybe, but they're just not tall enough to put anything in, especially in the cases like a box of parallels or collets or something like that. Like, so I'm still warming up to that, but we'll make do. Since we're on the show and tell theme, Stu picked this up, I don't know, a month or two ago, and it's a Derek's, end mill sharpening setup. Got it from a friend, and been doing some experimenting and playing around with it, primarily to sharpen like bigger cutters for for the Bridgeport thing, big high-speed steel kind of things. I don't know if This machine, especially if you're thinking like Grizz kind of things, I don't know how this thing does with like smaller end mills, but maybe we'll try it and see what we can do. But he's been spending a little bit of time on here and learning how to do it, and it's pretty cool because you really can take like a completely just shot out unusable end mill, high speed steel, carbide, whatever, and you can sharpen it. Like, you sharpen the ends, you sharpen the flutes, you sharpen everything. It's got a like an air spindle and your primaries and secondaries, and it's pretty cool. So that was a fun little addition to the shop. Quick side note, I almost forgot to mention, this is an attachment for that grinder, and I guess you can like put radiuses and do ball mills with it. Haven't actually tried that yet, but I guess that's what it's for. So these are a somewhat unique little job that came through. Yeah, these are custom 4-inch riser blocks for a Haas GR510. It's like a gantry router mill, whatever you want to call it. It's like 5 by 10 foot table, and the place that I'm working at is tooling up to put like right angle attachments on this particular machine, and to get the added clearance, they needed to raise it up 4 inches. So here's their 4 inches. These are actually weldments, 4-inch weldments, solid. Then they were stress relieved, and then surface ground. As you can tell, the finish is pretty killer. They weigh about 160 pounds each. And they're made to go onto the machine. You gotta, lift the whole gantry up, but these pass-through plates are so you can get all the wires, the umbilical cord through there without having to take everything apart. So, yeah, pretty cool project. Well, I think that's all I have, and keep this one short and sweet. So, yeah, I'll keep you posted. I'll get back into the video thing. I'll keep you posted on what's going on and what we decide to do on this current screw situation. And unless you got anything, no? You got anything? No? All right. Cool. Well, we'll make it that. Thanks for all the support and all the subscribers. Thumbs up, thumbs down. We love it. So take care. Shoot me a comment below, and we'll catch you in the next one. Thanks a lot.